Hello, welcome to the STEAM Club Online. As always, I'm Matthew, and joining me today is Jasmine. We're going to be talking about water in the world.
So water is great to study because it supports all of the life that we have on Earth and all of the different environments that we see all around the world. It's also great to study because it has really amazing scientific properties, which we're going to talk about today. The very first experiment that we're going to talk about is the water cycle. Now, if you're about 7 years and older, you would already know what the water cycle is all about. And if you don't, there's heaps of books, websites, videos, and even songs which teach you the water cycle concept. But today we're going to show you the water cycle and how it works and actually make it rain inside.
For today's experiment, you're going to need a glass jar, a bowl, some ice cubes, and some hot water. Now you're going to need parental help with the ice cubes and the hot water, and you're going to need to wear safety equipment with the hot water. I recommend getting your parent or guardian to be the one that deals with that.
With our jar, it doesn't need to be as big as this one is. It can be a jar like a jam jar or a pasta sauce jar. We are going to draw and show the whole water cycle on this. So I've got some textures here. You can use paper, cellophane, and even paint on the jar, but I've noticed that textures are really good to see the actual water and what is happening to the water cycle in the jar itself. So the water cycle starts off with water on the ground. So the water on the ground normally starts off in some lakes and rivers if we're in some rural areas. In city areas like we are in Playford mainly, they are in different dams and different rivers as well. So I'm just trying to draw that. There we go, you've got some grass growing here, and then we've got a really big lake. So with these really large bodies of water, the water on the surface of the rivers or the dams and the lakes gets quite warm because during the day the sun is just keeps pounding on it. So that water actually turns into water vapor. The water vapor evaporates, which is the first stage of the water cycle, and goes up into the sky. From there, all of the water vapor forms into clouds. So the clouds form different types, different shapes depending on the amount of water vapor, wind, and the temperature in the sky, and all of those different things, which is why you have different types of clouds. From there, the water vapor gets very, very cold and actually goes back down into the ground. So I'm going to show you that now. Let's show the sun. So from here, the water vapor forms into all of the different clouds that you can see in the sky, and from here it forms the very last stage in the water cycle, which is precipitation. So precipitation can be all different things from snow, hail, rain, and everything in between. So that's when the water goes back down to the ground, and sometimes it just runs off the dirt or the grass. Sometimes it lands on top of your roof, which is why we have drains, so it goes down into the drain system and back into the water cycle plant and maybe even our dams. So that's basically the water cycle. As you can see, I've done it very, very simply. I'm sure that you can do and decorate your jars a lot better than what I have. So I'd like to see all of your jars in the comments below.
So, we're back. We had a bit of a cut there because we needed to boil the kettle. So again, get your parents or guardians to help you with this. So we're pouring this in. It's relative to the size of your jar, so you don't need as much water as we're going to need. And you can already see that the evaporation is getting onto the side of the jar and causing some water vapor to hit there. The reason for this is the temperature differential. Same with the plate on top, our bowl. We've got it filled with ice cubes. The cold is interacting with the hot, this is what's going to cause our precipitation. The water's going to build up until it's going to start raining down.
So remember what we were talking about before with the water cycle. So the surface water in your lakes and your rivers is really hot, and it's going up and creating the steam, the water vapor, which is turning into clouds. You will notice when the water cycle is working, if you lift up the bowl and you can see the water forming on the bottom, and you can see a little bit of water or rain, precipitation happening, that means that the water cycle is working. One thing to note or remember about this experiment is that the water needed to be either really hot or really cold for things to happen. So the water on the surface of the earth or the ground needed to be really hot to go up in the sky to form the evaporation stage and form into clouds. And then coming back down, the water needed to be very, very cold to form into precipitation, to come back down to the ground to form to be rain or snow or sleet or things like that. We're going to focus more about those different properties of water, either being really hot and what that means, or really cold and what that means as well, in our next experiment.
Hi guys, we're back with the second of the two. So this operates under much the same principles with the water movement. So for this one, we're using a 600ml bottle that we filled with cold water. We've dyed it blue and we left it in the fridge for a while. We're going to be using this bottle as well with the hot water. As you can see, the hot water actually deformed the plastic, which is another concept we can go into at another day. And we're going to fill that one with red food dye. Now, you're also going to need either a Stanley knife or a drill. And at this point, you need a parent's help to do this. Do not attempt this yourself. We're just putting a small incision in the lid so we can hold them underwater and nothing can come out, and we can squeeze and it can escape.
So the incision that Matthew was talking about, he's putting that at the top of the lids. I'll show you.
It doesn't need to be huge, it just needs to leak out.
Right.
So now we're putting the food dye in here and we want it really red. Cool, and let's pour the hot water in.
So remember, this may be the best time to get an adult to do this for you, because the water needs to be freshly boiled. And be careful, because as Matthew said, the bottle is going to have to form. And it's going to be messy. Okay.
It's because this isn't a very large tank. We're not going to hold them. We're not going to hold them horizontally. We need to hold them straight down. I'm going to take one side. You're going to take the other. So we're just going to tip it straight upside down, put it to the bottom, and then squeeze. So you can see with the blue coming out, it's going straight to the bottom. Where you can see the red, it's moving up around the Coke bottle straight away, and it's coming to the top. Let's give it a good old push.
It's very hot on my fingers.
There, you can see it's moving straight to the top, and we have a clear separation between the two. We'll just leave that one floating for now because that is quite hot. And you can see as I'm pushing the blue one, it's going down and not actually rising, where the red isn't actually coming down at all. So there is a clear difference in the way the water moves depending if it's hot or cold. Now, why this is interesting is because it is actually affecting the ocean currents in the world. So we were talking about ocean currents before. In this case, we're going to talk about the EAC, the East Australian Current. Now it moves south from Queensland down to Tasmania. Now this is warm water flowing down south, and so what that happens is it affects the climate, because the warmer water has the wind coming across it, it picks up the heat, and then it moves it across inland, and so it creates a warmer climated weather. Now, the reason why this is a bit odd, it's not odd, it's a part of the natural process, is that other cities at the same latitude, so the same height as, say, Sydney and Victoria, won't be as warm, and that's because of this ocean current. Now, it doesn't move very fast considering, because underwater currents don't move actually that fast, but compared to the static that is most of the rest of the oceans, it actually does move quite quickly. That's why we have these ocean currents moving all around there. It's why we've got the weather phenomena of La Nina and El Nino, and we've got the Gulf of Mexico stream, which moves down from south of Mexico up towards Newfoundland and then moves across into the North Atlantic current. That's why Florida in America is quite warmer compared to the other side. So ocean currents do affect climate, and it's why we need to be listening to science and looking about how all this functions. So it's good to listen to the science and the ocean currents and see how that affects weather, because it does affect things like hurricane patterns as well.
If you want to see the EAC in action, watch the Disney Pixar movie Finding Nemo, and the main characters actually follow that from Queensland through to Sydney.
Now, thank you for joining us. As always, I've been Matthew.
And I've been Jasmine.
And for science, see you next week.